10,080 chemical reactions. That is how many a robot ran in 3 months after GPT-5.4 suggested a fix for a reaction medicinal chemists have struggled with for years. On June 17th, OpenAI and a Polish chemistry company called Molecule.one published something unusual. They connected GPT-5.4 to a high-throughput lab, asked it to improve a specific chemical reaction, and then tested what it came up with in the real world. Thousands of physical experiments, measured and validated. The reaction is called Chan-Lam coupling. It attaches two molecules together with a copper catalyst. A nitrogen from a sulfonamide bonds to a carbon from a boronic acid. That bond shows up in dozens of FDA-approved drugs. The hard part is primary sulfonamides. In the baseline tests here, the average yield was about 17%. Most of the starting material went nowhere useful. OpenAI asked GPT-5.4 to brainstorm fixes. The model generated ideas, ranked them, and the best one, proposal OAI-M1-03, said to add a mild oxidant called tempo. Tempo was already known in organic chemistry. The useful move was connecting it to this stubborn reaction case and predicting that it would help. Here is where it gets physical. Molecule.one has an automated lab platform called Maria. Maria AI translated the model's proposal into an experiment plan. Which chemicals, which concentrations, which plate layouts. Maria Lab, the robotic system, then ran those experiments across 96 substrate combinations, 12 sulfonamides times 8 boronic acids, under many different conditions. 2 screening campaigns, over 10,000 individual microscale reactions. The data came back clear. Under the best tempo conditions, mean yield rose from about 17% to 25%. The fraction of reactions that crossed 30% yield more than doubled, and 88% of the boronic acids tested improved. Then came the part that separates this from a lot of AI chemistry demos. The team picked 14 representative pairs and ran them again by hand at bench scale. 11 of the 14 improved. 8 improved by more than double. The vials looked different. You could see it. Darker product, cleaner separation. So what does this actually prove? First, GPT-5.4 did not discover a drug. It proposed a reaction additive that improved yields for a specific coupling reaction. That is real chemistry, but it is one step in a much longer pipeline. Second, this was not autonomous in the science fiction sense. Human chemists wrote the steering prompts. Humans chose which proposals to test. Humans corrected the experiment plans Maria AI generated, and humans ran the bench scale validation. The system worked because of everything around the model: the lab robots, the experiment design software, and experienced people who knew when an idea was plausible. Third, these results come from OpenAI and Molecule.one testing their own system. External experts reviewed the work, but the stronger test is still ahead. A different lab, different equipment, same reaction, checking whether tempo really helps. The interesting part is the loop. A model that can propose, a lab that can test at scale, data that feeds back, and people who can judge the result. It started with a prompt on March 4 and ended with a published, inspectable result on June 17. If another lab reproduces it, one bottleneck in testing chemistry ideas just got smaller.